Hello everyone, in this video we're going to learn how to plot a graph which will help you in your physics IAs. So what we're going to do right now is we're going to do an experiment between the length of the pendulum and the time period for one oscillation. So let's get started. So here I'm displacing the bob by about 10 degrees and let it oscillate. So 1, 2, 3, 4 and that's 5. So basically this time period, which is 5.57, is a time period for 5 oscillations, but we need a time period for one oscillation. So what we'll do is simply divide this value by 5, right? Anyhow, but we'll continue doing for more trials as well as for different lengths. Fast forward, I have a data over here for different length of the pendulum and the different trials for each length. Now we have to find out the average of these trials. So I just simply applied the function average and selected the cell from C4 to E4, and that gave me the average value as 5.63. This is for length 0.30. Similarly, for length 0.40 up till 1.00. So these cell over here representing the average time period for 5 oscillation, but we needed a time period for one oscillation. So what do I need to do now? We'll simply divide these values with 5, right? So what I'm going to do, I'm just typing equals F4, which is a cell over here, 5.63, divided by 5. Done. That gives me the value of one oscillation. And similarly, I've done for every single cell over here, F6 by 5, F7 by 5, F8 by 5, and so on, F11 by 5. So right now I have the values of length of the pendulum and respective time period for one oscillation. So now we have to plot a graph, the graph between the length of the pendulum and the time period for one oscillation. So we'll make another table, a simple table which only includes the length of the pendulum and the time period for one oscillation. So let's plot the graph. So for that, we just need to select the data table and click on Insert, Chart, Scatter Plot. Yes, so that's a graph that we have got. This graph is between length of the pendulum on x-axis and the time period on y-axis. So what is the relationship? It's not a straight line, right? What graph is this? We'll do one thing. We'll include a trend line and we'll see which is the best fit. Linear fit is not the best fit over here. So we'll change it to some other function, say power. Yes, that's perfect. You can see the power is the best fit for this data points over here. So what does that mean? That means that the time period is directly proportional to the length to the power of n, right? I repeat, this graph represents that the time period is directly proportional to the nth power of length of the pendulum. So we have to find out the nth power of length of the pendulum so that we can plot the graph between nth power of length of the pendulum and the time period, which will be a linear graph. So please note, students, you must know about this, that we should always plot a linear graph, right? We should try our best to get a linear graph. So let's do a simple mathematical calculation over here. Let me start recording. Yes. So let's do a simple mathematical calculation. The calculation is, over here you can see the graph that we got is not a straight line, but basically a curve like this, right? On y-axis we have the time period of the simple pendulum, and x-axis we have length of the pendulum. That gives us a relationship that the t is directly proportional to L to the power of n. But how will we find out this value of n? For that, please note we have to apply log on both sides, which is log t equals log L to the power of n. That is going to be log t equals n log L. That means if I plot the graph between log L on x-axis and log t on y-axis, it is going to be a straight line. And the slope of the line is going to be my value of n. So let's go ahead and do that. So what I need now, I need the value of log L, that is over here with you, and we need the value of log t. So what I've done over here is simply applied the log function, as you can see over here. I applied the log functions to the values of length over here. So the cell over here is B26. So I applied function as log B26, similarly log B27, log B28, and so on, log B33. Now we needed log t, so I have a t values that is in the cell C26, so I've applied the log function, log C26, log C27, and so on, log C33. So let's plot the graph between the log L and log t. Click on Insert, Chart, and Scatter Plot. That is the graph between log L and log t. As I mentioned before, it will be a straight line, and the slope of the line will be the value of n, which is the power of length. So let's plot the graph. Insert chart element, trend line linear. Yes, we got a straight line and we wanted the slope of the line. That means we need to display the equation on the chart, and that's the equation that we have over here, right? Perfect. So what is the slope of the line over here? The slope of the line is 0.4826. That's a line equation that we have got. Y equals slope of the line times x plus c. What is the line equation slope? It is about 0.5. I'm writing down over here, that is slope of the line is about 0.5. That means the power of length is 0.5. So let me write it on the board over here. The power of length, which is n equals 0.5. That means y, as I mentioned before that t is directly proportional to n to the power of n. That means t is directly proportional n to the power of 0.5. That means t is directly proportional n to the power of 1 by 2. That means t is directly proportional to the root n. So if we draw a graph between the root of length and the time period, we are going to get a straight line. So we'll see whether we are going to get it or not. Let's check. So for that we need a root length, that is we have over here, and we need time period. Time period just simply copy pasted from here, nothing else. But root L, so what I've done, I've used a function sqrt, which stands for square root, and the values of L is in the cell B26. That's what I've done over here. You can see sqrt B26. So square root of the value in the cell B26. Similarly, square root of the value in B27, so on, square root of the value in B33. So all these values are the square root of length, and all these values are the time period. So let us go ahead and plot the graph between root L and the time period. Click on insert, chart, scatter plot. Beautiful, we got a straight line. To see this, let us include a chart element, trend line, linear. It's perfect straight line, right? And we'll display the value of r square. What is r square? R square value ranges between 0 to 1, and closer to 1 represent the best fit. Farther from the 1, that means closer to 0, represent the worst fit. In this case, as you can see, the value of r square is equal to 1. That means it's the best fit, right? The best fit, nothing can be better than this. Anyhow, coming back to this graph, yes, so that means we can conclude saying that the length, the square root of length and the time period, if you plot the graph, it is going to give a straight line. And we can give a relationship saying that the time period of the simple pendulum is directly proportional to the square root of length. So that's how you plot the graph. That's how you linearize a graph. To linearize a graph, you need to know the value of power. To know the power of n, to know the value of power, which is n, you need to apply log function and plot the log graph and get the value of slope of the log graph. As you can see, we got the slope as 0.5, and that was the value of n for us. We continued with that n, which is basically L to the power of n, and we got the graph as a linear graph. That's all in this video. In the next video, we'll talk about uncertainty calculation. As you can see, I have not discussed anything about uncertainty over here, propagation of uncertainty in this case, because this video is all about how to plot a graph and how to get a linear graph. Bye. Take care of yourself.